Here I have a system of 3 equations with 3 variables. And what I found in the past is that when people solve a system of 3 equations, they make far fewer mistakes if they use the addition method. So let's solve this problem that way. To do that, the very first thing that I want to do is to make all of the coefficients on one of the variables into opposites. I'm always going to start with my x's. Looking at the 3 x's in the 3 equations, I know that 3x, 2x, and 1x are all going to go into 6x. So what I'm going to try and do is get 6x in the first equation and then the opposite of that in the next two, negative 6x and negative 6x. To make that happen, if I look at my first equation, I currently have 3x. To get 6x, I have to multiply by 2. So I'm going to multiply the entire first equation by 2. 2 times 3x gives 6x, 2 times negative y gives negative 2y, 2 times 1z is positive 2z, and 2 times 4 is equal to 8 on the right-hand side. Same idea with equation 2. I currently have 2x. I need a negative 6x. To make that happen, I have to multiply by negative 3. Distributing negative 3 across the equation, negative 3 times 2x is negative 6x. Negative 3 times negative 3y is positive 9y. Negative 3 times positive 2 is negative 6z. And then negative 3 times 6 on the right-hand side will give negative 18. Finally, in the third equation, I currently have 1x. To make it a 6x, negative 6x, I have to multiply by negative 6. Negative 6 times negative y will give positive 6y. Negative 6 times positive z gives negative 6z. And on the right-hand side, negative 6 times 2 is negative 12. Once the coefficients on x's are opposite, I can add my equations to eliminate the variables. But I'm always going to keep 3 equations in my system. First equation I'm not going to touch, I'm just going to bring it along, and I'll use it later for solving for x at some point. Copying that equation, I get this. And then to eliminate the x in the second equation, I will add the first equation and the second equation together. 6x minus 6x is 0, so that term disappears. For my y's, negative 2y plus 9y is 7y. 2z minus 6z is negative 4z, and 8 minus 18 is negative 10. The same idea is going to happen in the third equation. I need to eliminate the x's. I'll do that by adding equation 1 to equation 3. 6x minus 6x is 0. Negative 2y plus 6y is 4y. 2z minus 6z is negative 4z. And on the right-hand side, 8 minus 12 is negative 4. Once I'm here, if you notice these last 2 equations only have 2 variables, I can solve for y and z using the addition method. But I'm still going to keep my system of 3 equations together. I'm not going to touch the first equation, I'm just going to copy it. 6x minus 2y plus 2z has to be 8. And then in my second and third equations, I want the coefficients on one of the variables to be opposites. And while it would be easier to make the z's into opposites right now, I'm always going to do the y's until I'm really comfortable with the method. So 7y and 4y both go into 28y. I'll make my y term in the second equation positive, and then I'll go for negative 28y in the third equation. So to make that happen, my second equation is currently a 7y. I have to multiply by 4 to get 28y. Distributing the 4, I'll get 28y. 4 times negative 4z is negative 16z. And on the right-hand side, 4 times negative 10 is negative 40. To get a negative 28y in equation 3, I currently have 4y. I'll have to multiply that by negative 7. And then I'll distribute negative 7 across the equation. Negative 7 times negative 4z is positive 28z. And on the right-hand side, negative 7 times negative 4 is positive 28. So here in my next step, again, I'm just going to keep that first equation the same. And I want to eliminate the y's in the third equation. I'm going to keep the second equation, and then I'll add the second and third equations together to get rid of my y's in that final equation. So copying the first and second equation, 6x minus 2y plus 2z is 8. 28y minus 16z is negative 40. And then again, to eliminate the negative 28y in the third equation, I'll add the 28y from the second. Those go away. When I add up my z's, negative 16z plus 28z is 12z. And on the right-hand side, negative 40 plus 28 is negative 12. Once I'm here, I can start solving my equations for the variables and back substituting them into the equation or into the system to get the other variables. When you look at equation 3, that tells me that 12z has to equal negative 12. If I divide both sides by 12, I'll have solved for z, and I'll know that z is negative 1. That value from equation 3 can be substituted into equation 2, and that will tell me why. So in equation 2, I know that 28y minus 16 times whatever z is negative 1, has to equal negative 40. When I solve this equation, I'll get 28y plus 16 is negative 40. I'll subtract 16 from both sides to get 28y is negative 56. Dividing both sides by 28, I'll know that y is negative 2. Finally, once I know the value of both y and z, I can take those values and substitute them into equation 1. Equation 1 tells me that 6x minus 2 times whatever y is negative 2, plus 2 times whatever z is negative 1, has to equal 8. Simplifying on the left-hand side, I'll have 6x plus 2 has to equal 8. Subtracting 2 from both sides, I'll get 6x is equal to 6. And finally, dividing by 6, x is equal to 1. And at this point, I know the values of x, y, and z, so I can write my ordered triple as 1, negative 2, negative 1.